So now you have a firm idea of what it means to say one fraction is smaller than the other. Good? So then, now so I just go straight to the symbols because I want, so you can read up. It's all in the book, right? So if I have Mn, KL, I cannot do this unless, yeah, can write if M over N is bigger than the K over L. That's how, it's the same as saying, you say 5 minus 2, that's okay if you know 5 is bigger than 2. Once that's done, so let's ignore that for the moment. Let's say, so how do you do it? So it's the same thing. Different denominators, no good. We fix it, right? So this is the same as. So we're on the same denominator. So NL, NL, right? But if that's what you want to do, this requires what? What's the numerator? ML. And this? Okay. You say as this, and you know how many parts of 1 over NL? Minus, okay, I have it let me define for you subtraction, but you know exactly how to define it? How do you define it? L. Yeah, how do you think we're going to define this? You know how to do this. Because what we say, can it be different from the meaning of subtraction among whole numbers? Can it be different? Cannot be. Must be the same. So for whole numbers, you say minus 2. How do you explain the kids?
Go right 5. Right 5, left 2.
5, left 2? Okay.
Like on a number line, go 5 right,
yes,
and then back 2 left.
Yeah, but if there's something, yeah, that's good, but this, you can do it more simply by saying what? Take something of length 5, right? You know the take away interpretation of subtraction. You take away from one end a segment of length 2. What's left? That is what it is. You agree? That for whole numbers, in terms of the number line, that's what subtraction is. 5 minus 2 is what? Take a segment of length 5. Either end, doesn't matter. I usually write it right end. Take right end, take away a segment of length 2. What's left over, that's what you call 5 minus 2, right? So that being the case, how do you think I'm going to define this? Well, same way, exactly same way, right? This is why you need M over N to be bigger than K over L, right? Now, by our meaning of bigger than, if I look at the segment of length M over N, how does it compare with the segment of K over L? Bigger because of what?
Larger.
I know. Longer because of what?
It's to the right.
Right.
But yes, I know it's to the right, but tell me.
Because KL is to the left.
Yes. Therefore, okay, so KL is smaller and N is bigger. Therefore, the segment of length M over N compared to the segment of length of K over L, which is longer. Of course. Of course, right? This is why. So you draw a picture, you can see it. This to the right, therefore this segment longer than this segment. So coming back to that, so you got that decided?
Oh.
Sorry?
I just, never mind.
You just, yeah.
No, I wanted to are you labeling then the section in between those two as M over
Yes, of course, it's the same. Oh, you want that, okay.
Yeah. Sorry.
This is K over L, M over N, right? So that means this is the segment of length M over N. This is the segment of length K over L, right? So guess what is the difference of the two fractions?
M over N minus K over L.
You take away the segment of length K over L from the segment of length M over N. Take away, subtraction is take away, right? So that has to be this is the length of the segment that's left behind after you have taken away a segment of length K over L from one end of the segment of length M over N. Good? Now, don't forget, you do that to show your students that you're not doing anything new. Doing fractions is not a different kind of numbers. It's the same as what they have been doing all along for whole numbers. There's no gap, there's no crisis in learning. So in that case, well, when you understand this, this we have seen the same as this. Right? So what do you think the answer is? You understand all that?
M over ML minus NK over NL.
Exactly. All right, Glenn, explain to us why this is true.
Well, kind of like what you're saying on the example that you gave, if what's left is you're taking away the length of ML,
Exactly.
and then if you take away NK, what's left is the difference between the two numbers.
Yes.
But your denominator still remains the same, which is the whole length that you divided it into.
Okay. All right. Does
know if
anyone
that's a
want to
good
put it a little better? That's correct. But can anyone, if you explain it to your students, can you do better? Meaning, phrase it in a way that makes it more obvious? I don't know.
So if I had the 1 over NL as my, like,
Your
Unit
yardstick, your
length.
yardstick,
my what?
yardstick.
My yardstick, or, yes. And then what I have, how many of those I have are ML minus NK.
Right, because you have to march n or times L steps to get to here. Correct? And you walk only NK steps and you already get here. So, from here to here, how many more such steps do you have to take? That's clear. It's what about? ML minus NK steps. But how long each step? Each step is 1 over NL, right?
Yeah.
So this is the total number of steps, each of length 1 over NL. That's why this one is. See, now see, I want to understand, we don't have time to talk about this too much. That all these are not just say, I memorize it by rote, this is, oh, it got to be like this. It's not that, it's exactly what you have said. Subtraction means, what fraction is, what taking something away, that's exactly what it says.
But before our steps were the whole unit segment, 0
Yes.
to 1. And now we're just changing the size of the
Exactly, right? So it's important to show children that what they're doing is not something they have to, not something because you made up, and they must follow. You want them to see, well, look, yeah. If I were to do it, I would do the same thing too, right? And if they can feel that way, then you're already way ahead. Okay? You would wonder and say, well, it's all pictures, and bigger than KL, then you can say, so that's the answer. But let me ask you, did it ever occur to you that maybe this doesn't make any sense? ML may be less than NK, in which case what's going to happen? Then you have no game to play, right? If this turns out to be 115, and this turns out to be 195, then you have no game to play. 115 minus 195, that won't work. Correct? Wait, do I make sense to you?
Yeah.
We do this subtraction blindly, just symbolic, without thinking, right? What if by accident 115 is minus 195, if that happens, you're in trouble. So my question is, why doesn't it happen?
For initial, you stated up above, your assumption is Mn is greater than K over L.
Therefore, what did we write? If Mn is bigger than K over L,
Then ML.
ML
less
is
than
bigger than okay, see? It all fits. See, I just want you to know it all fits. The various thing you do, you think that, well, you know, one is just to subtract, the other is to say compare. They're not related. Oh, they are. They are very much related.